effort to come here and takes a lot of time. And I think you are as busy as we are. So we appreciate that you take the time to.
It's not as much about being busy. It's if I do a lecture like this in Europe, I prefer to go by train.
Yep.
And that makes it a 3-day exercise. And that was, and combined with the Corona restrictions, I don't like to sit in the train with the mask and so on. It's all a little bit too much.
Yeah, we fully understand.
Yeah. But I hope this works. I'm very happy that we set it up like this, because now I can actually see you all, and that's kind of.
Yep. Great.
The biggest handicap is that you're all wearing these face masks. Okay.
Yep. So I don't know if you have been told that two students will present you, and you have to listen very attentively, because this is all knowledge we know about you from the internet. So please, comes to you.
Okay. Hi. So correct us if we're wrong. It's just the information we found about you on LinkedIn.
Okay. I'm interested.
So about Césare Peeren, he graduated in Delft University of Technology in 1997. And from then on, he worked for 5 years as chief editor for the Omslag magazine, which is focusing on social.
That was before graduating.
Which is focusing on social participation and integration of people with disabilities. Right. And you also wrote critical architecture review and much more. In 2012, he founded the architecture practice 2012 Architekten with Jan Jongert, which is now Superuse Studio. To integrate more sustainability in architecture. And the practice became the inspiration and root for the beginning of circular architecture. And in 2004, you started teaching Superuse design methodology in Sheffield School of Architecture. And Anna will say more about the Superuse Studio.
I can imagine you're gonna explain a bit more about it, but so Superuse Reuse Studio is based in Rotterdam, and your architecture and design studio focus on superuse. Superuse, what does it mean? It's highly valorized reuse of residual and scrap materials, to which the studio gives a new life with elegant and sustainable solutions. And as I understood, like Superuse focuses about the architecture, the projects, and then you have also harvest map, like material, it's an applications for harvest, and then pulse up urban, it's focusing on urban metabolism, so the flow in the urban area. But I imagine you're going to explain it. Thank you very much.
Explain everything, but I can, because I'm not explaining Harvest Map in the lecture, I can say that it's an online platform to other designers to understand where what kind of waste is available and in what kind of quantities. So because waste is only waste because it's in the wrong place at the wrong time, and with a map where you can see where the resources are, you can actually design with them and when they come available. So that's the idea about Harvest Map. The dates are a little bit wrong. We ran a magazine, a critical architecture magazine, while we were studying. Jan, my co-founder, me and Jeroen and a few more people, until 1997. Then we started 2012 Architects, that we transformed into Superuse Studios in 2012. So we are nearly at our 25 years of existence now. And we changed our name also because it became, 2012 was in the future when we started. So that sounded like something for the future. And we hoped to be kind of ready with transforming architecture into a more sustainable practice by then. And in 2012, we made it Superuse Studios because we have several studios now that work from the same philosophy, but are completely independent economically. And locally based. We have one studio in Beijing. One studio is now emerging in California. My studio is on site, so I always work on location. And the main studio is in Rotterdam. And we chose for that. I'll explain in the lecture also, so I'll come back to that. Should I just start?
Yes, please.
Sorry. Yeah. Is the audio good? Can you all hear me?
Yes.
Yeah. Let me know if it goes down or something. So this was Zurich online then. Last time I spoke at In Situ was in Basel, I think. So that's why I imagined it would be in Basel. Well, that's what I just referred to. There is no such thing as waste. Waste is actually resources that are for some reason not being used because they're on the wrong location or they are available at the wrong time. And then they get disposed of, which is a very unnatural way of dealing with materials. The construction industry is a very big part of that. We cause about 30% of all the waste and 30% of all the CO2 emissions. So that's a lot to win there.
We say it's 40%.
Yeah, it might be even more, I know. And this I find also an interesting thing, like we're constantly building and rebuilding our cities and the buildings. Like quite often concrete buildings are torn down to replace them with sustainable buildings. And I don't really understand how you can think that that's sustainable. I understood that the structure you're in was a temporary structure and will soon be demolished, which gave it quite a long lifetime, but I still don't really, I had a walk through it with Kevin this afternoon on his iPhone, and I think it's a very valuable district of the Zurich school. So it's a bit of a shame to tear it down. I think it needs structures like that in a school. Well, this is where we started. After we were studying, we came to the observation that a lot of waste was being recycled also. And we found one company in Rotterdam that was actually recycling 50,000 washing machines every month. And that's only the washing machines from Dutch households. And that seems so incredibly much, but that is actually true. If you calculate the lifetime of a washing machine and the amount of people in Holland, then that is really what happens. And then it's a lot of energy to bring a quite interesting material down to basic resources again. So we thought we have to do something with that. And we made this quite iconic object with it, which for us was not a piece of art, but for us was really a prototype for architecture. And we were also quite happy that it ended in the, well, not happy that it ended, but we were quite happy that the University of Delft decided to buy it from us after it had been traveling Europe for 5 years. And it became an espresso bar. Unfortunately, the whole building burned down 1 year after due to fire in a coffee machine, not ours, luckily. There's another waste stream. I think this is a picture of the American desert. You can even see it on Google Earth. There's like thousands and thousands of airplanes waiting to be scrapped. But also in Dresden, there's a company that is in Germany that is scrapping airplanes. And from that we got obviously, the aluminium gets recycled and has quite a high value, but all the plastics that are in it are basically an environmental hazard and a problem if you want to recycle them, because they are very difficult to recycle. They are the same kind of material that windmill wings are made from, which is a composite material, hard to recycle, so very important to reuse actually, because it's if we don't use it, it will get burned. And it has really nice properties. It's lightweight, it's acoustic. This is used to improve the acoustics in this music room. And it really works because we were reusing this space, which is a square box, and we wanted to make it into an auditorium. And the acoustic advisor said, yeah, well, you shouldn't have a square box. It should have angle. The walls of an auditorium preferably are on an angle. Because then you get good acoustics. But the other option is to make the walls like multi-formed, and that's what we did with the forms that are in these panels, and that made it into an auditorium that has its own acoustics. It's not dead. You don't completely kill the sound, but it has a resonance that is actually, it works like an instrument, which is what our client wanted. They didn't want, because currently most auditoriums are made that they don't reflect any sound. And then the electronic devices make the acoustics. And this is an auditorium that has its own sound due to the plastic we used from the airplanes. I'm talking too long about this, but then the lecture is going to be long. But anyway, the cable reels, that's another resource that we've been using a lot. And I realized we have been using a lot of materials that are not part of the normal architectural language. And the reason why we've been doing that, especially in the beginning of our practice, is that those materials are wasted in big quantities and are usually standardized materials. So these cable reels have standardized sizes. With that, you can make, well, this is just a first exercise we did, an art piece that we made to cross the river with, where we actually use the turning capacity of the cable reels, but then later we started using it in interiors. And then the fact that it's very standardized material starts to help making a kind of a logical design from it. And also the curved forms of the materials, like I have a few samples here. You see that it has this curved section, but that's used to make the benches with rounded, ergonomically rounded forms. That's what we kind of always are looking for when we design with waste materials, is that we try to figure out how can you optimize the use of the qualities of the material, which I saw also. I've seen a few of the mock-ups. For instance, the one with the stones that you've made. I think you really managed to discover what are the typical properties of those stones to create as well aesthetics as really functional use of it. I think that's really important in our work, that we always look for a way to functionally reuse the waste. Another thing, can you see my cursor? Yeah, what you see here, for instance, this is a piece of metal that makes the table, which is also, hey, hello, which is also a part of the cable reel. And these are the metal rods that keep the cable reel together. And even these things that are the feet of the tables are the rings that keep those metal rods in the cable reel. So we try to optimize using all the elements in a functional way. I have trouble with my screen. Does that happen to you too?
No, it's fine.
Okay, on my side, the image just disappears all the time. And then, after having used this material for an artwork, for interior installations, we knew enough about it to ask a contractor to use it in building, cladding the facade of this house with it. And in this house, like 60% of all materials are reused. But most materials go through this kind of development in our practice. Like we do small scale projects with it, sometimes workshops with students, then we do interior projects with it, and then we start using them in architecture, because then we know enough about the material that we can ask a regular contractor to work with it. Well, this is one of the problems we're facing. We're using much more resources than the planet can provide. We're using about 2 or 3 planets every year. That's why people like Elon Musk are completely crazy and want to extend it to other planets now. I think we can't even take care of our own planet. How can we think that we can create an ecosystem on another planet? It's just weird arrogance. And we are also having quite a big impact on nature, amongst others, by mining a lot of the materials that we. What I find really weird is that we're doing this, and then we use stuff for a few seconds to a few years. But the things we do for it are quite yeah, they have an impact forever. And they also have impact on people's lives. And the only way to stop that and war, I think there's a lot of bullshit on the television why we have wars. I'm pretty sure it's not about religion. It's actually about resources. It's about oil, and it's about keeping the prices of resources low enough that we can throw them away, which is quite bizarre and perverted. So I think one of the why this reuse of waste is so important, and I think also the transformation of existing buildings, we are coming to the point now that we say we have mined enough and we should actually stop it. And I think we should actually, as architects, refuse building new buildings. We should transform what is already there and use materials that are already there, because then we can turn this system around. Because now we are basically constantly mining incredible amounts of resources to be able to build new buildings. We do a bit of renovation. We use some bio-based materials. We do a little bit of recycled, and a very small bit, some pioneers like us are using materials again that are already there. I think if we turn that around, we start not building new buildings, but optimizing everything we have. We have so many bad buildings. We have so many, like the building you're in now is beautiful, but it's probably energetically quite a bad building. So instead of breaking it down, you could look at the building like, hey, can I make this into a climate machine? Can I improve its climatic qualities? And what kind of waste materials are coming free in München that I can use to do that? And then if you looked at all those things, you add a layer of bio-based materials, recycled materials, and then you end up using like much less mined materials. I don't say we have to stop completely with the mining, but if we can reduce it to like 10% of what we're doing now by taking all these other steps first, then we can have quite a big impact on the rest of the world in a positive sense, that we can stop having war about resources because it's not needed anymore, because the cities start recycling, are in a circular system. This is a project that we did in the center of Rotterdam. This was before we did it. You see all the windows here are, most of the windows here are closed, or also here behind, because there was there used to be a photo institute in that building that did exhibitions in the dark, because they exhibited movies and slides and that kind of stuff. And they had archives that couldn't have daylight. But then we were asked to put locate WARM in there. And WARM is a multicultural organization that has offices, shops, a concert room, and a movie room. And the concert room, movie room, and all the bars and so on is what we call the red WARM. The yellow one was all the shops, and the green one the offices and the facilities. And we found out that if we want to locate them properly in the building, we have to make one strategic change in the structure of the building, and then we can actually organize all those functions in the spaces that were already available without demolishing anything more. So we made one small incision by putting a gap in the facade, putting the facade forward and creating an entrance and a staircase behind that entrance that connects the basement layer with the first layer, and that connects the offices, the concert room, and the shops. And that's and by doing that, we could reuse all the spaces that were in there and change as little as possible to them. That was step one, transforming the existing building in a very precise way. Even it went that far that there were dark rooms in the building from the former functionality that were there, and also WARM as film studios, so they could use those dark rooms literally exactly how they were. And there were toilets and showers that we didn't have to build again. And just by making that good investigation of the existing building and understanding where we would have to change something to optimize the use. And the next layer is adding materials, and then not using any new materials. So we make a harvest map. So the harvest map is two things for us. It's a tool that we use when we start a project to understand what kind of waste will be available when we will build the project. So we can design with the waste that is actually available in Rotterdam, to build a project in Rotterdam. So we don't have to transport waste, because we try to reduce also the transport energy. And the other harvest map that we have is an online platform where we have collected all the information about waste that is available in Holland. And we've actually privatized that. That's now run by a different company. We are not running a harvest map anymore. And that's good, because they are spending their time on it. And we still add things that we discover. And that's also, by having this way of thinking and this tool, it also makes you design differently. You have to design from the materials that are available, and you don't first design something and then look if you can find the materials. You first look what materials are available. You understand what is a bit the structure of the project. How much seating do you need? How much flooring do you need? How much insulation material? And based on that, roughly, you start looking for materials that can perform that. So we knew that we needed about 2,000 square meters of very solid flooring for people to dance on, and thousands of people to walk on every weekend, or hundreds of people, but over the years, thousands and thousands of people. So it has to be really hard and solid material. And flooring is quite expensive, so you also have a budget. And we found actually a company that was selling office furniture, and they had what you call dead stock. That's material that is actually new, but is difficult to sell because of several reasons. In this case, it's fashion, the reason. This office furniture was in a color gray that was popular in the 80s. And he somehow had 2,500 of these office desks in stock, and that he could never sell again. Other colors he could sell, but the gray one was impossible to sell because nobody wants it anymore. So our challenge was to develop a pattern to lay these desks in. And the other interesting thing was that, of course, it is Trespa. It's I have a piece here. And it's completely this light gray color. It's a 9 millimeter thickness. It's a high pressure laminate, so it's a very hard pressed wood actually. And the top layer is also quite hard. But we found out that, and it's very slippery. So if you spill some beer on it and you start dancing, people will fall. So it's not good for a floor. The only good thing for the floor is that it's very, it doesn't wear. Basically, it never wears. So we decided to kind of like sandblast it. And then this is the gray top layer. And this is sandblasted very rough bit. And also the guy selling it told us like, well, you can't, well, since you're going to use it as a floor tiling, I suppose you're going to cut these difficult triangles off. So I give you a discount for the square meters of the triangle. And of course, that made me think, okay, can we make a pattern, a laying pattern in which we use it? So the pattern that is sandblasted on it represents also the pattern in which the floor is laid. And that becomes kind of a decorative element, even though it is designed from a functional perspective. We got really enthusiastic about the material, so we also started using it for the plinth, the lambrisering, the first 1 meter of the wall. And in this is hidden the ventilation system. This is the other material from airplanes, the composite, lightweight, and with a lot of form. So, and we needed something that was light enough to not have to create really strong or extra strong structures to carry it. And that what I explained before, to improve the acoustics of the auditorium. And then we also integrated the LED lamps in it. And the ventilation, the air, the dirty air that is taken away from the ceiling goes through these holes and then is ventilated away in the plenum that's above that. this is a different project, recent project. It's like it's a bar. But what's interesting about it is it's located near Stripe S, which is a big transformation area. So a lot of the materials that, basically all the materials that were used came from demolitions that take place in that area on the other side of the highway. And it used to be a school. This school. And the school was changed, the function of the school was changed into atelier and ateliers that regularly do exhibitions, and that people working there wanted to have a lot of contact with the neighborhood around it. But the building itself, as you can see, maybe it has one big entrance, and this wall is still quite open. The other side is very closed and relatively small windows. So the building feels a bit close. So they asked, and also it was due to regulations, it was very difficult to put a public space in the building. That would have, because of fire regulations, fire brigade, we would have to change so much about the building to integrate it in the building, that we decided to build a pavilion outside the building on the former school square. That's where that was made. And then we made a harvest map, and we found that there was a lot of the heavy materials were actually just across the road, and the lighter materials came from other places in Netherlands. We found these wooden structures that by chopping a few of them in pieces, we could redesign them into the main structure. And another aspect of this building is that it's demountable. So that's why all the bolts, we didn't glue anything. Everything was mounted and like dry fabrication. So nothing, the whole pavilion can be taken apart and transported somewhere else if for some reason it's not wanted on that spot anymore. You can see also in the floor we used concrete slabs, and you can see the lines between them. They are just stacked. The foundation is stacked. That's what you see here. So we used standard concrete elements, and the metal came from a demolition on the other side of the road, and then insulation, and stacked it all up until you got a floor, and on which is then the main structure built. Then another material that we worked a lot with is another composite material. So this is the wings from the wind industry. In what I find interesting, we've been working with wind blades now for 15 years, and I've just been to a wind conference also to get to understand if we can work together with them, because they have really a huge waste problem. But the more I start to know about this renewable energy form, the more I get scared, because the impact it has is incredible. It's this is the foundation. You see the little men, huh? And this is a land-based windmill, so it can't even be that big. The ones that they built in the sea now have 90-meter blades. If you understand that the 55-meter blade, that's the biggest one we've ever worked with, is 17,000 kilograms of composite material, impossible to recycle. They're handmade. That's also interesting. So there's like people making these things by hand in a mold. There's a lot of labor going in, a lot of transport, a lot of materials. Transport is really expensive and requires a lot of changes. They even have to take lampposts away on crossings that they want to cross, etc. And then we throw it away. But that's the whole thing that I don't understand, how you can, even if I saw some presentations on that wind conference, even if you understand that the CO2 emissions are less than if you use fossil fuels for the same amount of kilowatt hours, I still think we cannot afford to waste resources in this kind of way. I mean, the planet is getting to an end of being able to deal with that. So I don't believe that we're going to solve the climate crisis by installing megawatts of energy production on the sea with this. I think we need a completely different approach, but I'll come to that later. First, what we do with the waste. So that's kind of like still, okay, we try to extend the lifetime of the waste to, and we're now finally the wind energy, after 15 years of trying to get to them, they are now asking us to come to conferences and show what we can do with it. So we made this seating object that is actually quite ergonomic. The funny thing is that the aerodynamic forms of the wing, the curved forms they have, are very nice for your back. So they naturally have a form that feels good to your back if you make the angles properly. So in this case we didn't change anything to the wings. We just mounted them on a concrete block, which is 60% reused waste also. In the playground we changed more because there were also bigger blades. These are like 35 meter, 3,500 kilogram of polyurethane foam, epoxy, resin and glass fiber, of which 2,000 kilo is glass fiber, 1,500 kilogram is all kinds of plastics and fossil fuel based materials. They're now moving towards recyclable blades, but that will be available in about 10 years from now and much more expensive. But anyway, this became quite a nice playground. The kids like it a lot also because you can go in. And these kind of spaces, what I think is really nice about reusing this kind of waste is that it comes with so many assets. It has so many beautiful things. It has beautiful spaces. I mean, you could spend hours and days modeling this kind of 3D forms. And well, we don't have to model them. They are part of the waste. And then you get a project that has much less impact because not only we save the waste from being wasted, we also don't need virgin resources to build a playground. So it makes quite a big difference in the impact it has on the planet. And it can last forever. I mean, these playgrounds can, this one is now there for 15 years and it has been painted twice in the meantime. And that's the only maintenance it needs. It has to be painted. So I said before, like we are now several studios. This is the team of the studio in Rotterdam. Jan is the other founder. Together with Jan, we founded the company in 1997. This is the Chinese team. Gillian worked with us in Rotterdam for a few years and then moved back to China. And in the first 2 years that they started their Superuse studio, Jan has been traveling a few times to China. And we always think that that's kind of, yeah, well, we don't want to fly too much. So we basically educated the team in China to work with the waste in China, which is crazy. The amounts there are staggering. It's like, yeah, they found one company that produces window frames with double glazing for the European market, and they always produce 10% extra. And with that 10%, because then they are sure they have enough, and that gets thrown away. And that 10% is enough to start a building firm and build skyscrapers in China with it. It's like, you can't imagine how much that is. And this is my studio. We are called Superuse on-site, and I've changed the focus a little bit towards community living and building architecture that is not only made from waste and bio-based materials, but also improves the energy performance of the building. And even though all your workshop has been about waste reuse, I think it's a very important thing to think about. This is again, this kind of like, I started to see that everything we do as a humanity is upside down, basically. We I showed you before how we deal with resources. I think the same applies to how we deal with energy. And applied to architecture, most architects design a building from some kind of concept that's based on more or less things. Sometimes it's just an aesthetic concept, sometimes it's based a bit on flows of people through the building or functionality, quite often. But when we first started working with waste, a lot of architects told us like, yeah, but I don't want to work with waste because then I'm not free to design whatever I want anymore. It's like, huh? Okay. And if you want to take into account the climatization of your building, also you're not free anymore. So that's a bit, so people try to still make the same kind of architecture that we've been making for the last 100 years. And then you just add a lot of technology to make it sustainable. And we think we should turn it the other way around. You should basically think about the building based on climatic ideas about how is it oriented, where is the sun, what's the size, can it be smaller, what's the shape, is it a really complicated shape that loses a lot of energy naturally, or can you make it more compact? Can you insulate it properly? Can you put the program in it in such a way that it needs less heating by zoning it properly? Can you also make the architecture in such a way that sustainable behavior is easier than anything that is wasteful, like that you close your curtains properly or whatever is the behavior that is needed? Then passive design, and then you need a very little bit of technology to make it work. You only need a little bit of solar panels instead of a lot, and that's a bit related to this archetypical windmill from the Dutch history. What is the situation with these things? It's like they were built in such a way that they could be moved. So they are industrial, flexible, demountable buildings already. They were made in a way that they could be taken apart and moved. They were made with materials. They were insulated with straw that was grown around them. The windmill family was living in it. It was also a house, and it was a production facility. It made, for instance, it ground the wheat to make the bread that was used in the village next door. There's a whole circular lifestyle going around. We did a calculation also how efficient these things are, and even with the wooden machinery that's in it, they are more efficient than, or let's put it this way, if you harvest the energy from the wind on a square meter of surface of the wings, the loss of energy towards making a kilogram of ground up flour to bake the bread with, there is it's more efficient to do it this way than sourcing it on the sea, transporting it through these copper cables to the land. Then it goes into a factory, it's transformed into a different voltage again, and then they ground the wheat with it and bring it to the shop. That whole system is much more inefficient than the old-fashioned system, and that is due to the lifestyle, is due to the directness, and due to the much less resources needed to do this whole process. So I think there's a key to making to saving, to stopping the climate crisis, and the key is also in this story. This is the story about termites, and this is a city that termites live in. And in this core of their city, they produce food, and they work together with mycelia to do that. And they have their eggs in there, the eggs for the newborns. And that needs a very precise temperature and moisture situation. So they have to climatize this perfectly. And they do that without machinery. They let air in through the ground, and depending on where they are, these channels are longer or shorter. Depending on where they are on the planet, there is more porous. The outside skin is more or less porous to deal with the water vapor going out or in, or more insulation or less insulation. And it's fully passively climatized. And they have food production in their city. So they don't import food from South America if they have this city in Europe. We do that. And the other interesting thing is that they are with more than us. And that's quite obvious. If you've seen a termite heap, you see how many they are. They are much more than us. You would think, yeah, that's an obvious remark. But they are more than us in kilograms. There's more weight of termites and ants on the planet than humans. And they have a positive impact on the planet. And they live in cities, like us. So I think it's not even overpopulation the problem, it's our lifestyle. I think it would be wise to slow down in getting more humans, because I think it's a really dumb idea to assume that we have to be 10 billion in a few years from now. I think it would be wise to slow down, but it's the combination of overpopulation and our lifestyle which creates the problem. So we can work also on our lifestyle. And that's where this kind of other kind of approach we are having now to the architecture is like, can we make houses? This is a prototype for us. We call it the greenhouse. And here we tried to do the best we could to use barely any virgin resources and barely any energy to heat the house. So what we did is that one thing is that we build it with the community that lives in it, a bit like the barn raising that the American Amish do. So we made quite a simple wooden skeleton design that could be made by people that are not skilled workers. So they could invite a lot of friends and a lot of volunteers to help build it. But to have all these volunteers and friends working on their plot for nearly 2 years, it was in the end, they needed facilities. So they had a lot of land. It was the good thing about this place where we were working. So they started, they were already growing food, but to facilitate the food for all their volunteers, they needed a bigger garden. So they made the garden bigger and started producing more food. They started a bakery. They started a mushroom growing facility where they grow mushrooms on coffee, on ground coffee. And they made several tiny houses on the plot, which after the project was still beneficial because they've learned to bake the bread, they've learned to make enough food, and now on Saturday there's a small shop for the people that live around them that come there to buy the bread from them and buy the biological food they produce. And they rent out the tiny houses now. So they have created, with building this house, they've not only created a house, but they've also created a small local economy where they are actually producing food locally and having a relationship with the environment around them and making the whole place more sustainable by being more able, like the ants, by producing your own food, producing your own energy. So that's, it started, it's a wooden skeleton made from wood that like 50% of it, 60% we found on site because they had a collection of wooden beams. And one thing you can see, I don't show it here, maybe you can see here that this, the column is, it gets smaller to the top. So in the ground floor, we added wood to carry the weight. And when we go up, we don't add these two here. So we get a skinnier, and it gets skinnier all the time. So it follows also what is needed for the forces. So to be a bit more efficient with the material. And this is a B choice or second-hand insulation. This is not biological at all. This is kind of what we shouldn't make anymore. But since we're still making it and there's a lot of waste of it, we used it for the roof. And also in the building process, we put the roof on before we started filling in the skeleton. So we had actually a covered building site. And also the glass house was put on before we were filling in the lower levels. The glass house was interesting because the constructor told us that you can have people standing in a glass house picking tomatoes, but you can't have people living in it because the rules for housing is different than the rules for glass houses, even though in both cases there are humans under it. The danger is the same, I think, but still, so we had to use a different glazing, which I understand, like a layered glazing in the roof. But we also had to put, I don't know if you can see this detail here, that we doubled the columns. And that column that is here is actually the column we cut away on this side. So we cut one column from the glass house and added it to this one. And that way we could actually use it for a house. It fitted the regulation. It was quite simple. But the interesting thing in working as an architect is that the constructor first says, yeah, you can't make people live in a glass house. That's not possible. But then you talk with him like, okay, but how can we make it possible? It's really a lot about involving everyone in your design decisions early up. This material is then bio-based. They live in a farming area, so it was quite easy to find insulation material. This is really 100 meters up the road from the farmer next door. We used that to insulate. And there was a demolishment taking place in Leeuwarden, which is 80 kilometers up the road. And these houses were demolished, and the glazing is actually double glazing that still fits the current building regulations, HR+, because these houses were renovated in, if I remember right, 2006. And but this was then the south facade. And you see, so on the south side, we have a glass house, then a south facade with a lot of windows, and the north facade has very little windows. So that's really an important decision to make. If you want to source the heat from the sun, the north side is where you lose heat, basically always. So you want to minimize the amount of windows in the north facade. And use only small windows. And on the south facade, we have the glass house, and then a layer behind that is the climate barrier with a lot of glass in it, so we can get a lot of the solar heat into the house. Here you see also what it does to the microclimates. So by having this house, you create, it seems obvious, but you have to understand it and work with it. We create the cooler shaded north side and the warmer with parasol, the warmer south side. And these microclimates you can use for changing the temperature in the house. Also, this is the zoning bit from the pyramid that I showed you. Like by zoning, you mean also that like on the north side you put storage, bathroom, stairs. Bathroom you use 1 hour a day, so you can just warm it up for that 1 hour a day. And then in the core, you have all the functions that need more warmth and a more comfortable climate. So you reduce incredibly the amount of cubic meters that you have to actually warm. And you place them next to the glass house that gets the sun in winter. And here you see the 3 layers in pictures. Like that's the north side. Hallways, storage, vertical staircase, which also helps in the ventilation, the rooms, and the Serre glass house on the south side. And then in winter, with the low sun, a lot of the sun comes in and heats all the thermal mass. We have a lot of mass in the floor. We have a lot of mass, especially in the first sections of the walls here, that gets warmed by the sun, and that keeps the warmth in the house for several hours afterwards. But also you can work with the ventilation, like the warm air, the air that warms up and that ventilates those rooms, and then you keep this side closed. While in the summer you do the opposite. Basically you let the way to warm air create a draft up, because when the sun shines it just gets incredibly hot. It gets like 40 degrees in the glass house. So you use that to create an updraft. And that updraft is strong enough to pull air from the north side through the house. And on this side, like we measured, we have like 21 degrees on a day that on this side it's 30 degrees. And in the glass house it gets 40 degrees. And like that, we actually cool the whole house down to 21 degrees, which is when it's 30 degrees in the sun, feels like really cool. And then what is left is a little bit of technology, 16 solar panels that do all the electricity in this house for the 4 families that can live in it. And it also supplies more electricity to another house that's 50 meters further. And these tubes are for showering and the warm water. And then we have 1 or 2 mass heaters in it that use wood that is grown on the plot where they live. But normally in Holland, you would have this kachel on for about 4 or 5 months over winter. And in this situation, we're down to 6 weeks, 2.5 months, depending a bit on how cold the winter is. The rest of the time, the house is comfortable by using the possibilities of letting the sun in, closing the curtains, and harvesting the heat from the sun. And behavior. The people that live in it also understand that they have to wear warmer clothing when it gets winter and accept that the house can go down to 17 degrees. But if you dress properly, like we do in our house too, we have woolen underwear, and the house is like 16, 17 degrees when it gets really cold outside. We accept those fluctuations. Another, I think, very important change in our lifestyle would be to change the way we deal with resources. At this moment, for most cities, if this is a city, most of the resources that are used, the food and other resources, are actually imported from the rest of the planet. A part of it is from your own country, an even smaller part comes from the region, and practically nothing comes from the city itself. Imagine you would come to a situation where most of the stuff we use, most of the food we use in the city, most of the resources we use can be either made in the city or repaired in or just around the city. And less comes from the region, even less comes from the rest of your country, and practically nothing comes from the rest of the world anymore. That would have a huge impact. And it used to be kind of normal. This is like a way where fruit was grown in France by creating microclimates with walls. That could, and also even in Holland, we were growing grapes 80 years ago by creating microclimates. And then if you look at the city thinking about that, then I cannot look at this is Rotterdam, obviously. I cannot look at this without thinking, okay, this is kind of a mountain. Why isn't anything growing on top here? Why in this valley here, it's just grass? Why can't this be productive? Why can't these trees all be fruit trees? This is just a collection of valleys and mountains and a landscape to grow food in. And if you start doing that, you get a completely different city. You don't have any fine dust problems anymore. You don't have water overflow problems anymore. You can climatize your buildings properly because also all these trees, like in the house that I showed you, there is nothing growing on the north side. We've planted trees and bushes there to create an even more cold climate on the north side, because then if it's full of plants, then you get natural evaporation in summer, and that reduces the temperature also, which is a natural way of making an evaporative cooler, which is basically an air conditioner, but without using any electricity, just using nature, and then you can grow some food in it too. So you have yeah. So that's kind of principles that we're now trying to apply on this the next project that we're working on at the moment. This is being built at this moment. This is a one-floor community building that was built in the 60s. It has a patio with a tree. This place is a marriage hall and a garden. And it had been used as a community center. It has been built as a community center with a library, marriage hall, all kinds of public facilities. Then it was left empty and was squatted about 18 years ago a group of idealists, and they started opening the building up to the neighborhood again. So they turned it back into a neighborhood center, and they started growing food with people from the neighborhood. And at some point, like 6 years ago, they were nearly evicted and finally got to talk to the owner. And the owner is a housing corporation, so they have to build social housing. And they said, we have a problem. We should build 23 houses on this plot. And now you are living there with 7 people, and that's not enough. So we have to build more houses. And then the 7 squatters said, but that's not a problem. We would like to live with more people here. Maybe we can work together. And then they were told that the Social Housing Corporation was going to finance the project if they would take the lead in developing it. And then they looked for an architect, and that was us. Then we got the assignment to design for them. When we first analyzed the situation, again, you see on the north side, this is the north side, we actually have trees already, fully grown trees and bushes. So we have a really cool north side, which is kind of perfect situation. And then we have a really warm south side to the building, which is an black asphalt parking lot. And the building in between. So, but to make 23 houses, we had to put in 3 houses with each 6 apartments. And here another 5. This is based on what the carrying capacity of the existing foundations. We could put 1 floor on this bit, which was quite interesting because there, you see it's narrower here and it's wider here. And the construction was made in such a way that there's the same amount of foundation poles in this area as in this one. But since this is less meters, we have more carrying capacity in this part. So we could actually top up 1 layer of housing on this one, and we had to make new foundations for all 3 houses. So we put 1 in the patio, 1 in the marriage hall, and 1 in the garden. And to compensate for the loss of garden that we had, we decided to make all the roofs into gardens, roof gardens, that are accessible from the houses. So if you live here, you can go onto your roof garden and you have your salads and everything that you have growing here. Also, even though these first 2 are community houses, I can show that here. So we have also a social, it's a community of about 40 people, of which about 10 to 15 live in this house, 10 to 15 in this house, 10 to 15 in the house in the garden. And those 2 are like they have a communal kitchen in this area. So that's 15 people using 1 kitchen on the ground floor. And the one in the garden is 6 individual apartments. And like that, we create a lot of diversity in housing size. And also by having a lot of common space, we could reduce the size of the houses. So that's the first layer also where you think, okay, if you have a smaller house, you use less energy. So all these people have quite small apartments. They go from 25 square meters to 75 square meters maximum for a whole family with children. And a lot of the common spaces, original common spaces of the original building will become common spaces for the neighborhood again. So this part will become a restaurant or a food place for shared between the whole group and with the neighborhood. This is where they're processing the food, and this will become a workspace now. At this moment, we are processing the waste material so the contractor can work with it. When the building is finished, it will become a social workspace where people from the neighborhood can come to repair their bikes, repair furniture. Also in this whole idea, like if we change our lifestyle, we have to facilitate lifestyle change. So what is needed? If we want to stop importing materials from China, we should be able to repair stuff in our cities. So that's what this space will become, a repair shop that facilitates that for the whole neighborhood. But then you get a bit of a kind of an ecosystem of all kinds of ways of sharing, all kinds of ways of growing food, naturally ventilated, needing much less equipment to actually climatize the building. And it's built 100% with waste and bio-based materials. That's that's a bit our mission at the moment, that's our mission at the moment. And since we, like a week ago, we received a prize, which is quite an important prize in Holland, that is annually given to, usually to an architect that is like 75 years old and has done a lot of work and had a big company building all kinds of big buildings. And this year they decided to give it to us, and for a reason, because they said that we have put on the agenda circular design in the last 25 years with our work. And we've actually convinced a lot of other architects to work like that too. And now we are, what we say, like, we're actually at the start of a change. Building with waste is just one aspect of building sustainable. The things I showed in the last two projects, I think, are just as important, if not more important, is that we actually make our cities better and make our existing building stock better by improving their energy use, and also improving the communities in our cities, so people can start sharing stuff again, and people can help each other repairing the stuff they need, and that cities can actually become ecosystems like the ants and the termites. And we want to collect all, there's a lot of people that have been writing about that. There's a lot of research been done to that, and we want to make a book that actually collects all those ideas, and we want to make that available to everyone that is interested. And because of that, we've now started a campaign where people can book the future. And we're selling 500 books for 600 euro. That's not a little bit, but the idea is that that money is used to create the content, collect the content, and make an open source website that spreads all that information to anyone that wants to know. So we want 500 people to finance that mission. Well, that's any questions? But maybe the light can go on in the room. I don't hear you, actually. I'd like to talk with you. That's why I've asked Kevin to set up it in this way that I can see you. And I mean, I'm curious if anyone has anything, any remarks, questions, ideas.
Yeah, this is just a small question, but going back to the windmills, I was just really surprised by, I mean, windmills, it seems like a relatively young thing, and it's surprising to see that so much is already being discarded. And do you know why those blades are thrown away and why they can't be used anymore as windmills?
Yeah, there's several reasons. Some of them are, in my opinion, legitimate, and some of them are just perverted economics. Yeah, I know a lot about this, so I can tell you a long story, but I'll try to keep it a bit short. Is that the first thing we knew was that they get discarded after between 15 and 25 years for technical reasons. They are made with glass fiber. They turn around sometimes at the speed of sound, near to the speed of sound, the big ones. So they get a lot of physical, there's a lot of tension on them. So if small cracks start appearing in the structure, they have to be discarded because it's way too dangerous. They can't break. They're not allowed to break up there. So they are checked, and if small cracks are in them, they have to be discarded. But that's a small part of it. The other part is that they actually don't have a longer technical lifespan than 25 years, like a lot of things that we make. And I think that's a system failure in our way of working. We should not make things that only last one generation. I mean, that's ridiculous. I mean, the Indians used to say we have to think 7 generations ahead. I think it's a weird idea to make stuff that only lasts 20 years. So we should spend more time developing things that's technically longer during. The perverted thing, the economical reason, is that in Holland, for instance, and in a lot of countries, there's a subsidy system on wind energy because it's considered sustainable. The subsidy system works like this. You get a subsidy for building a wind park. You also get a subsidy for 10 years on the kilowatt hours that you produce. After 10 years, this subsidy stops. So at 10 years, there's quite an interesting moment. You can actually, wind energy has not stopped developing. You can replace your windmill that produces a certain amount of kilowatt hours with a new one. You get subsidy on the replacement, on building that new one. The new one is much bigger, so it generates much more kilowatt hours. There's a demand for more kilowatt hours from the European, that's been decided in Glasgow. The wind industry is super happy now. We're going to invest billions into wind energy, which means they have to repower. They have to take away the old wind parks and replace them with bigger ones to be able to supply the demand. And economically, that's interesting for them because they get brand new subsidies after 10 years. There is a small second-hand market, but that small second-hand market is not capable of dealing with this second-hand, huge second-hand amount that is coming available now. I was at a wind conference 2 weeks ago in Brussels, and they explained how they, to reach the targets of Europe, they have to replace all on-land wind farms in the coming 3 years. And they're not that old because they need to be bigger, because it's easier to replace an existing one with a bigger one because there's not so much resistance from the people in that area because it's already there. And the subsidies help. So that's quite a, yeah, not so nice story behind the wind industry. And I'm always quite annoyed when I see windmills being portrayed as one of the solutions to our problem. I think we should use the ones we have as long as we can, and we should really work on reducing the energy we need. And that's for us, that's an interesting task. I think it's not, I don't even understand how people can see it as a problem, because I think you get the best architecture. You must have noticed also in making these mock-ups, you get the best architecture if you have more constraints. I mean, it's really interesting to work with the climate, and it's really nice to work with it. It makes for so much better buildings. I think it's, yeah, I think that's, I don't know how it is in your studies, but when I was studying in Delft, they literally told me, well, don't worry about the climatization of the building. You just reserve about 20% of space above the ceilings for installations, and that's it. And the climate engineer will do the rest. You just think about space. I think that's the wrong education. You have to think about architecture as a climate machine, and that's, yeah, gives such more interesting architecture.
I have a question about your harvest map. You talked about them as if you had them quite quickly after the command. We know them, we use that tool, but most of the time rather late in the process, because to get the materials, we need a lot of time, and sometimes it's like 2 days before we use the materials that we find the pieces. Can you maybe say 2 words about the way you find the materials for your command? Do you have?
I get the question. Yeah, that's why we make a specific harvest map for every project we do, where we map out what kind of materials would be available at the time we're going to realize the project. And every waste stream has a different, I'm tempted to want to show a harvest map, but every waste stream has its own logic. Demolishment is indeed quite a difficult one, because demolishers usually get their job, they get like 6 weeks or something to sign up. And then when they get chosen, within 2 weeks, the building has to be down. So that's a very fast system. That's one of the reasons why, especially in the beginning, we focused on materials that were outside architecture. So like the windmills, like the parts from airplanes, because they come from production processes and they are identical materials and you can count on them. You can design with them regardless, because there's this company that does a certain project and also has a certain waste, and it has that waste every month. So you can actually plan on it. Another interesting one, I think, is are things like exhibitions. Exhibitions are planned, are designed, built, and you know exactly when it stops. So you already know exactly what material went in, and you know exactly when it will become available. So if you work with exhibition designers or exhibition places, you can plan on the waste coming available like a year before it becomes available, usually like half a year before. Demolishers are now getting more interested because circular architecture, I don't know how it's in Switzerland, but in Holland, circular architecture is really promoted and it's become a thing. So there are more and more demolishers that have changed their process in such a way that they can supply anything that they're demolishing. And also there the planning is a little bit more difficult, but architectural elements are in a way not that difficult, because like I saw one of your mock-ups where the windows are made independent from the structure. And that's a good strategy, because then you can, we say to the beauty committee that controls our design, we apply for a building permission and we say, yeah, that's going to be double glazing. We don't know exactly how the pattern will be, because we don't know yet what window frames we're going to get in 1 year from now, because we're talking to the demolishers and we don't know exactly what it will be, but it will be a pattern of windows. And then we design it in such a way that it's not depending on the construction. So we are free to design that pattern of the windows when we have the material available. But that's a little bit the tricks we use. And another trick is to disconnect interior design from the architecture a lot, because in interior design you can do quite different things than in the architecture. Was that an answer?
Yeah. Good.
I have a question. I'm a bit depressed.
Do you hear her?
Because
Not good enough, no?
Maybe take that.
You hear me now?
Yeah, very good.
Yeah, I'm depressed today because I talked to some politicians this morning and they were fighting about zero CO2 by 2030, 2040, 2050, and they didn't want to come down from 2040. So I'm really, today I don't feel that we will make it. Do you think our work has an influence at all, what we are doing?
Yeah, I think it has a big influence. It's I don't think we can wait for politicians.
Yeah, that I fully agree. But if they don't follow and if they don't facilitate our work, for example, we made this big pilot project and we made another small and another small, but it doesn't make an impact. I mean, I'm teaching here now and I'm very happy about all these students who have similar ideas, but still today I'm really frustrated. Maybe you can help to make my mood a bit better.
Yeah, what helps me, I mean, I obviously have the same problem. I mean, going to a wind conference doesn't make me happier.
Oh, yes.
If I really start to understand the logic behind that system, yeah, I really lose faith. What I think, it's inevitable that we're going to go through a big crisis in the coming 10 years. I think the system is, if I'm honest, I don't want to be the doomsday prophet, but if I'm honest, I think our system is going to collapse within the next 10 years. The good thing is that every society has its peak and its collapsing moment, and that seems to be an 80-year cycle. And we are in the last 20 years, actually in the last 10 years of that 80-year cycle. There's a few interesting, it's called the fourth coming. And at this moment, we are in the collapse part. You can see that in everything. It means that after that, there will be a new paradigm, a new kind of way of thinking. And the best we can do is prepare for that and be the pioneers that set the agenda for that next thing. And our children will be the ones profiting from that. If we don't do it, all that kind of knowledge also gets lost. We've learned so much, we've seen what goes wrong, and we've also learned what is the alternative. I'm not sure if we are going to be able to stop the collapse. We can maybe make it softer, and we can make a good start for the next generations. I'm sorry to say it like that, but that's actually what I don't know if I lift your mood, but and the other side, the other scenario, if it might be possible to change, and then again, the only thing you can do is prepare for this different lifestyle, because also in a collapse of society, the best thing you can have is an autonomous community that can produce its own food, that can produce its own energy, that can recycle its own water, and that is able to improvise and build architecture from the waste that's all omnipresent. So I don't see any reason to stop doing it, because it's the way to survive the collapse, it's the way to prevent the collapse, and it's the way that is needed after a potential collapse. So in any kind of scenario, it's the only way to go.
Okay, so let's survive. That's the best option. Thank you.
Yeah, it comes down to that all the time. I think that's, yeah. We started producing food in our garden, on our roof, doing it ourselves, and that's the thing that makes me most happy. And we're sharing it with neighbors, and we're building community in the place that we live in. And then professionally, we're also involved in creating communities and building it from waste and making ecological systems. And maybe, okay, the optimistic thing is we can actually change. We actually have an impact on changing society. We did get that prize, which is really an important prize in Holland, because we are recognized of having a big impact on the architectural community in Holland. Not because we build such big buildings, but because we are changing the way of thinking, we're changing the way of acting of a lot of other architects. Yeah.
Okay, so hope dies last, isn't it?
Yeah.
Any other question? They say it's a good end.
Oh.
No,
Okay, sorry.
the-
That would be the end, but okay.
Okay. Do you make the end?
No. Yeah, but thank you very much, César. Yeah, I don't know. If no one has a question, then we'll leave you and hope that we can meet again, maybe sometimes live, and maybe share some project or share some knowledge again soon.
I don't know what is going to happen exactly with the book, but I would like to somehow, I imagine we can include some of the work that you are doing there too, in it somehow.
Okay.
We're
Yeah.
developing that.
You have the book. Do you have the book?
He's talking about his book.
Ah,
Okay.
Yeah.
we send you our book as well.
Okay, thanks.
No, I told him you'll send the English version.
Okay, but then you have to wait for September.
Yeah, that's okay.
That's okay. Yeah, you have the know-how, you don't need it.
We have a lot of time.
But maybe, yeah, if you're of interest, we can send you at the end of the semester some documentation about the semester.
Yeah, that would be great.
Mhm. Good. Okay.
Okay, I hope that I didn't make it worse. Yeah, it's it. Yeah, it's what it is. I think we will see what happens. Obviously I'm not sure that it's gonna collapse, but I think the signs are there. Nobody's sure. We'll see what happens.
Yeah.
I think it's gonna be an interesting time. Let's say that. Okay. Bye.
Good. Okay. Okay. Oh. There is also a thank from one of the people following the